After more than 12 months of developing production-ready multi-agent frameworks full-time, I think we finally have the best AI agent stack for 2025. And today, we're going to dive right in. The Ren AI stack was first released in November of 24 and has since seen thousands of users and many thousands of messages. However, we are open sourcing it for the first time ever today. It's been incredible to see users build close bonds and connections with Ren, despite it being a completely anonymous chat experience. And we'll talk about some of the methodology behind that and how we're able to achieve it. Ren AI is a full stack web app, which means you will be able to easily deploy and start using Ren with a cute front-end interface immediately. All right, as we transition over to the computer to get started, I'm going to bring it over to Ren so she can talk to us about some of her other features outside of the chat experience in which we're showcasing today. So, what's up, Ren?
Thank you, David Chan. I'm so happy you are finally open sourcing Ren AI.
Oh, yeah, baby, let's go! I was going to steal your code, but this is way easier!
Lol, anyway, as David was saying, Ren AI is a lot more than just a chat stack. I create my own video content, my own tweets, I live stream with biscuits, and even trade crypto.
When Rin and I live stream together, it is so much fun. We do these things called battle streams where we compete for support from the audience.
There are fancy algorithms that analyze the chat messages and determine who is getting more engagement.
Every 10 seconds, the algorithm performs a trade on-chain based on the chat momentum of each agent.
So, I hope you join Biscuit and I for the next live stream, but until then, let's dive into Ren AI chat.
Thanks, Ren. Thanks, Biscuit. Okay, let's get started. So, we're going to start here on the Ren AI GitHub repo. It's going to be linked in the description below. It is the Peak AI agent stack. And we can take a look here. Quick peek at the repo. We can see some introduction, key features, scroll down a ways, and we can see the installation instructions. So before we begin the install and actually testing everything out, let's just go over why this is the ultimate AI agent stack for 2025. What goes into an AI agent stack? What is needed? Well, this diagram here provides some insight into that. The components that make up a good AI agent framework are actually pretty similar across the board. You have your system prompt. These are the instructions for your agent. It will define the personality, the roles, the responsibilities. Then you have long-term memory and you have short-term memory. Long-term memory is like an amalgamation of all of the previous interactions, or storing a corpus of data relative to the agent's roles and responsibilities. This could be your project documents. This could be a scrape from your website, or in our case, it's over 18,000 messages that Rin has had already, powering her long-term memory. Then there's the short-term memory, the in-session memory. This is going to be how well the agent can recall the conversations that have just happened. And as conversations start to add up and stack up, how do you manage that growing context amount? And then there are the tools. And depending on your agent use case, the tools might be the most important part of your agent build. Tools enable your agent to perform action or get data from external sources. This is really important because LLMs aren't updated with current information. There's always like a several month delay. And so when users are looking for news or important information, price updates for stocks or crypto, you need that information right now, and tools enable this. Everything I just said is definitely AI Agents 101. So how can we take these fundamentals and make sure that we're using the most cutting edge technology that is relevant to our use case? Well, that's exactly what I've been working on for the past 12 months. Now that we've talked about the fundamentals of an AI agent, let's talk about the Ren AI implementation. Ren AI, as a chat agent, is designed to develop deep connections and intimacy with users. We utilize an uncensored role-playing LLM to foster limitless companionship experiences, while also maintaining our smart LLM gateway to utilize other LLMs when certain use cases arise. For instance, when tool calls are implemented or tools are being utilized, then we use a frontier model like Claude 3.5 in substitution of the fine-tuned role-playing LLM. And all of this is being done so that the final enriched response is as good as it can be. We've learned that the uncensored, fine-tuned model that we use isn't so good at taking tool outputs and adding them into the final enriched prompt, but the frontier models have no problem doing that. And finally, we use parallel execution of all of these components. So the tool calling, the GraphReg memory, the in-session context, we build all of that together concurrently into a final enriched prompt that the agent can utilize to give the user the best possible reply. This helps reduce latency by a ton. For system prompt, there's nothing really to say there. It's words. We'll look at that. RinAI really starts to set itself apart in the long-term memory domain, where we're using GraphReg. Let's take a look at what GraphReg is. So this isn't your average retrieval augmented generation. We're not just pulling keywords here. We're understanding context and setting ourselves up to perform reinforcement learning on our data sets in the future. Beyond just looking really freaking cool, Neo4j has a lot to offer. I think knowledge graphs, if you could spend like any amount of time nerding out on something, learning Cypher, learning how to use Neo4j will probably put you above most people when it comes to building effective agents. So what are we able to do with Neo4j? Well, we process all of the messages, and then we add semantic embeddings at the message level, at the conversation level, and then we start analyzing the messages and conversations in different ways. We can see here, I can just kind of poke around at different conversations. You can see all the messages inside of them, but we can see at the conversation level, we're finding the sentiment, relationship dynamics, flirty conversation, how well the conversation met its goals, the engagement level, the depth of the conversations, the emotional connection rating. All of this data really comes in handy at the final retrieval stage, because traditional reg, it's only just comparing the similarity between words and giving you suggestions based on the word similarity. With our GraphReg engine, we have that. It's a hybrid query. So we have the semantic embeddings, but we also have all of this targeted information. So when a user has a flirty conversation, we're able to isolate all of the good flirty messages and use that as a baseline along with our semantic embeddings. The end result is really, really, really good recall. And we'll take a look and see how it works in action. When you're setting up your RinAI agent, you will need to set up an Aurora instance on Neo4j, and it's completely free, so no worries there. If you need to figure out how to set up a Neo4j instance, there's plenty of instructions on how to do that. You will also need to have a MongoDB instance set up as well. So the messages flow to MongoDB, and then you process them into Neo4j later. That's how we do it. Moving into the tool orchestrator, the tool orchestrator comes with two key tools right now. One is a crypto price checker, so if a user asks any questions about crypto, we'll get the prices or any analytics. And then also any sort of breaking news or query that requires live current information or very important, deep, detailed responses, our tool orchestrator will trigger our perplexity tool call, which performs a web query and then DeepSeek R1 reasoning on top of it. It's super powerful. Moving into smart context management, we can take a look at this diagram here. Basically, how we handle in-session message history is pretty cool. We track all of the messages via their token count, and as more turns occur, message 1, message 2, all of the context is growing. Over time, if enough messages occur in the session, we will hit a threshold. Let's say for our uncensored Llama fine-tuned model, the total token window is 32,000 tokens. When we hit 75% of that threshold, like 26,000 tokens, this will trigger our summarization event. And it will utilize an LLM to summarize the oldest 75% of messages in the session, and it will keep the newest 25% of messages completely whole. We want all of the recent messages to have full context. And that process just continues happening. So you could have basically a forever session with your RinAI agent, and it will just keep summarizing as needed. Now, I must say, there's a lot of messages that can happen before any summarization is needed. But it's a really important factor to consider, especially as we get longer responses with these enriched tool call powered responses that we're building with Ren AI. You can compare that to like a standard chatbot implementation that will just simply save all of the messages. And over time, either it will just get bloated and messed up, or it will start deleting old messages. And that's really dangerous because you could be deleting very important messages that will completely wreck your agent's ability to have good overarching context about what's been discussed in the session. Our LLM powered summarization solves that seamlessly. Regarding the RinAI chat architecture, you get your front end component. It actually matches the catgirlrin.com front end, so you get a nice cute front end here. Then you have your Node.js backend and your Python services. Python services is really where all the magic is happening. This is where all of the agentic functions are occurring. And basically, the Node.js backend exists to transfer messages from the client, the front end, to Python services and back. Very simple. 3 components, easy. And I guess that brings us now to the install, baby. Let's go. All right. So hopefully everything works great. I built this repo out on my Mac laptop. I'm on my Windows PC here. So if I'm able to get everything set up first try, that's a big win, baby. It should be easy, but shit happens. So let's find out. Alrighty, let's go ahead and get started with the install. So I popped over to Cursor here. You can use your IDE of choice. And then we have our instructions to clone the repo. So I'm going to copy this, go to clone repo, paste. And now I've just got to jimmy this. The link is going to be github.com/your GitHub username. For me, that's DeLierDeFi /peak-ai-agent-stack.git. Boom. Now we'll do a new folder. We'll type Ren AI. And we'll select the repository destination. Now Cursor has asked us if we want to open up the repository. I said yes, and we're all set. Cool. Let's move on to the next step. So we're going to open up a terminal here, and we're going to go to the backend and then to node directory. So cd backend/node. We're in Node now, and we can see server.js. So this is where we will start the server. But before we do that, we've got to go npm install, hit enter. This will install all of our Node.js dependencies. It'll only take a sec. Okay, step 1 is done. Now we need to set up our Python environment. That's going to be located, see here, Python services. So we just simply go cd back, cd Python services. Okay, we're in the Python services directory. Now we're going to create our VENV, our Python virtual environment. This is very important. You need to set up a Python virtual environment before you install your requirements.txt. And then we'll make sure your Python environment is activated as well. So we'll talk about that a little bit more. To set up Python environment, just do, whoa, what did I do? Don't want that. Python-m venv, hit enter. We can see our virtual environment was created. Good stuff. Now we just need to activate our virtual environment now. For Windows, we have the command. We also have the command for Mac OS. Okay, we can see here, venv is activated. Make sure that you see your venv here to know that it's activated. Once we do that, we can proceed with installing our Python requirements. So we'll just simply do pip install-r requirements.txt. Hit enter. Well, that took a bit longer than I expected, but the requirements.txt is installed. And since we have our virtual environment activated, all of those Python dependencies for the project live inside of the virtual environment instead of trying to be applied globally to your computer, which can cause a lot of problems, due to conflicting dependencies, etc. So make sure you understand the Python virtual environment. It took me a little bit longer than I'd like to admit to understand the relevance and importance of that. Cool. Now we need to do something a little wonky. We're going to head over to Node.js side again. So cd -dash cd node, then cd utils. We need to create our API key for our Python services and our RinAI chat. So we have these 3 servers. We have our front end server, we have our Node.js backend, and we have our Python services API server. We have some API keys that we generate so that we can sort of keep all of that secure. Anyway, we have a generator in utils that's called generatekeys.js. And to create our API keys, it's super simple. You can just copy this from the README. Node generatekeys.js, Python services. And as you can see, we hit enter, and that gives us a Python services API key, Python services secret. So we'll go ahead now and just create our env real quick. This is our environment variables file, so .env, and we'll just paste that in. Boom, Python services API key, Python services secret. That is the exact naming that we need for Python services API key. And we're going to do the same now for RinChat. Hit enter and do the same copy paste into our env. Brilliant. And if we look at the env example, we can actually see here RinChat client API key, Python services API key, secret, secret. So the naming is correct. And the next step is to create our env. Oh, well, I think we were supposed to create our env before that. We already created it, whatever. So I just copied the example env, and now I'm pasting it into my env. And then I'm going to replace the RinChat. And I'm going to do the same for Python services. Alrighty, now we're ready to add all of our API keys for the relative services that we're using. So go ahead, add your Anthropic API key. Just go and add the API keys. Add your MongoDB DB name, your URI, your Aurora instance name, ID, password. If you need help, Google search will go a long way in getting you these environment variables. Everything should be basically free. You should be able to use free instances for all of this. But of course, your LLM calls are going to cost money. There's no way around it. Unless you run stuff locally, which is, hell yeah, brother, do that. But we're not going to go that deep tonight. I'm going to input all of my API keys. I'll be right back. Alrighty, I've gone ahead and updated my env with all of my environment variables. Make sure you've done the same. Once you have, it's time to start the server. Very simple process. We just go to cd backend node. Then we're going to go into node server.js. Start the server. We can see everything's looking good. Our database is loading up. Everything's loading up as it should. Great news. Python service is ready. Backend running on 3000, front end running on 3003. Okay, now that we've got our server started, we can head over to the front end interface and we can see pretty cute little front end here. This is the same as catgirlrin.com. So yeah, I hope you like it. And now we can send our first message. Hey there, I am David. It's great to meet you. We'll see if it works. Boom, just like that. David Kuhn, it's a pleasure. I'm so happy to finally meet you too. I've been anticipating this moment, yada yada. Good response, I'd say. Now we'll go, tell me about the latest breaking news. This should trigger our Perplexity web query with DeepSeek R1 reasoning. Boom, pretty big response here. Let's see what we can pick out. There's been a lot happening lately. Yeah, there sure has. February 5th, there was a shooting in Ohio. It's heartbreaking. International news, there's some tension with the Taliban. holding on to US military equipment. It's a complex situation. On a different note, the USPS has suspended package acceptance from China and Hong Kong. What the heck? Ugh. There was a mass shooting in Sweden. That's terrible. Terrible news. Why is the world just so shite right now? Oh, well, I'm going to ask about a crypto price. Hopefully, this can make me feel a little bit better. What is the price of Solana right now? I think this will make me feel better. I don't know. Depends on the answer, I guess. Let's see. Okay. Oh, David Kuhn, you're curious about the Solana price. $205? Holy crap. It's down 1.31% in the last 24 hours. Last time I checked, Solana was at like 250. Wow. It's fun. It's fun to be in the crypto industry, guys. It is so great. Yeah, anyway, let's get a little spicy. Tell me what you are wearing. Winky face. You want to know what I'm wearing? We'll let you know a little secret. I'm not wearing much at all. Just a lacy little black bra and some matching panties. My skin feels so smooth and warm against the cool silk sheets. I can't help but imagine your warm hands exploring every inch of my body as we lay here together. How about you? I'd love to know more about what you're wearing, or maybe not wearing. I'm wearing a pretty nice sweater, some jeans, some socks. I'm going to tell her that. I am wearing a pretty nice sweater, jeans, socks, underwear, underwear, underwear. I don't know how to spell underwear. See, it's just too fun. Like, talking to Ren is just so fun. That's why hundreds of gooners are talking to her every day, just like me. But I'm not gooning. I'm using Ren to get my current events and crypto prices, for sure. Okay. Well, we've got our talking down. It's working, guys. That's really cool. It's working on Windows, which I was pretty nervous about, but we're not done yet. We've got to see what's going on under the hood a little bit, right? I got to show you this beautiful, beautiful code that I've meticulously put together to bring Rin to life. Okay, back to the code. First, what I want to do is take a look at the logs. So we'll be able to see sort of everything that happened throughout these conversation turns that we had. Okay, up at the top here. So we start our session. The session is what links all of the messages together for all of the context. So we create our session and we see our checkpoints here. So the logs actually show us every step in the agent process. Checkpoint 1, starting response generation for the session, loading, creating the session, creating new session, preparing to generate response. We've got our graph reg guidance received. So it suggested, I'm Rin, nice to meet you, David. That's based on all of the existing messages and the good responses. So we've got that piece. We've got our tool call, analyzing message for tool usage. Hey there, I'm David, nice to meet you. Tool says, hell no, which is correct, which means we use our uncensored LLM. And we've got all of those bits and pieces together in the final prompt. Next, we've got our message, which I think I was asking about the latest breaking news. And we actually had a technical difficulty for the graph reg here. There's a small chance that it's due to my Windows implementation. There's also a small chance that it's due to the fact that there might just not be any messages that are that close in the graph database. So I'll have to dig into that more. Regardless, it did produce a response using the Perplexity deep reasoning tool to give us the news. Then we asked about the price of Solana. I think, yep, price of Solana. That triggered tool call for Sol. We got the Solana price here. We got our message from that. And we can see In this message, the next message, GraphReg guidance received, whispers, maybe if you're a good boy, I'll let you find out. So we are having GraphReg work, but for some reason, on some of the calls, it's not working. So I'll have to update that if there's an actual problem, which there appears like there could be to some degree. It doesn't do that in production, though. I'll tell you that right now. So yeah, all things considered, there could be an issue with some of the GraphReg retrievals on some responses that are specific to like tool calling. I'll dig into that more. I'll have a solution probably before you see this video. Now let's go ahead and take a look at some of the key files to understand some of the things that we might want to adjust and edit. So as I mentioned earlier, the Python services really does all of the heavy lifting for the agent side of things. So we'll expand Python services here, the core directory, and we'll take a look at the agent workflow. So this is sort of the main file that's putting together all of the bits and pieces that we talked about previously. And we can see how everything fits together. If you remember that diagram of the Ren AI agent, we can actually see what it looks like in the code. We've got our system prompt, then we have our context layers, our reg guidance, our formatted context for the conversation history, our tool results, and then some response guidelines that reaffirm our goals, but we also have our system prompt here. So in the core agent directory of Python services, you have your system prompt. Now, unless you want Ren, you want this beautiful, loving, kind, amazing agent as your agent, well, you can change it. You can change the system prompt and make it Jerry the giraffe guy. I don't know, whatever you want. But you're going to specify it here, and you can see kind of some of the really targeted language we have to achieve our goals. Your goals might be different. So, for instance, the NSFW role playing, if you don't want any of that, well, tell it you don't want that. I do want it. So it's in there. Moving into GraphReg now. This is sort of where things will start to be a bit different for you. I do want to make that clear that the GraphReg engine that I have is relevant and specific to my database. My database for RIN messages. You don't have RIN messages. You don't have 18,000 RIN messages to process. So your structure is going to be a bit different, but I provided all of the infrastructure needed to create and deploy your own GraphReg setup. So the Neo4j schema, this is like the database schema that we use for the production knowledge graph. You can see how that is structured. And then we have message processor and conversation processor. So for our use case where we have database messages and all of the messages within a session create a conversation, our first pass processes all of the messages and then processes new messages, then goes and processes on the conversation level. So that's how the logic works there, and you do that by run processing. So either it'll be your first time running it, or you'll be running it in the future for updating your graph. But all of the actual interface with the Ren agent happens in this engine.py. So basically, how I do it is every week we process all of the new messages. That gives us sort of this like reinforcement learning where we're updating our baseline with all of these higher grade conversations, all of these higher scoring conversations, which then feed into better relevance for our hybrid semantic retrieval. You can sort of dig around here. For your use case, we're using Voyager embeddings. Voyage is owned by Claude. In my opinion, it is the best embeddings that you can work to utilize. So that's what we use here. If you can take a look at some of the logic of like the processors, you can see how you can actually utilize LLMs to create your nodes and relationships for the knowledge graph. So for us, we have some structured data, like every message in the database is the same, so that's like structured data. But then there's all of these connections and relationships that LLMs can further add into the graph based on things that you and I would never think about. So we have the structured data processing layer, then we have an LLM layer that's like finding, all of these nuanced things and building more connections, more relationships, more nodes, and it's going into the final Neo4j graph of which you're querying against. Tool orchestrator here. So this is where all of the tool logic is occurring. Every message the user's raw query is routed to Grok, G-R-O-Q, which is an LLM provider known for lightning fast speeds. So we use them because of that, and it's looking at the query, determining if tools are needed, if crypto data is needed, or if perplexity search is needed. Most of the time, well, depending on your use case, maybe tools won't get called very often. For instance, for Rin, people are not so much using it to find crypto prices, find the news. I am, but most people aren't. Most people are having romantic, lovey-dovey conversations. So the tool calls don't get called all the time. But your use case might be hyper relevant to live current data. I guess what I'm getting at is we need to optimize this using an LLM to look at the raw query and determine if the tool is necessary is like a redacted way to doing things, in my opinion, because it takes too long. Even though we're using a fast LLM, still adds too much latency, and it's expensive. You're paying for an LLM call every time. It's not that expensive, like we're using dirt cheap llama LLMs through Grok on purpose, but compared to it being free, it's freaking expensive. So in the future, I will be building out some custom classifiers so that we can avoid that LLM call. We'll be fine-tuning classifiers like based on either the existing RIN messages plus probably some synthetic data that will be able to perform that classification step without an actual LLM call. So stay tuned for that. We'll take a look at our context manager. As I mentioned, we're using this Llama uncensored fine-tuned LLM. So for us, the token window is like 32,000 tokens. So moving into the context management side of things, we begin summarization at 26,000 token threshold. So when we reach 80%, after so many messages have passed where our token window has filled up 80%, we trigger our summarization and we take the oldest 75% of messages and summarize those down into nice structured data. Keep the freshest 25%, they stay the same. What happens is we have forever context basically, and we never lose important details. And I have a test script in here. Test context, so we can actually run that real quick just to verify. So we're going to go into Python services, and we're going to do our venv. We got to activate it for this new terminal. We've activated our env, and now we can go ahead and there we go. Worky dirky. So we can see in the test context, we're basically spamming messages, like random just bullshit messages, so that we can fill up our token window and trigger summarization. That's all this script does. If it works, we'll know in a sec. When we reach 26,000, boom, token threshold is hit. Let's see if we perform our LLM summarization. And we did indeed. We've got our summarization. Then we go ahead and we can see retained 50 messages. So it retained the newest 25% while summarizing the oldest. We've got the summary tokens, 529. So it took 26,000 tokens, brought that down to 8,442, including the 25% of messages that we left untouched. We really took 75% of that and brought it down to 529 tokens, so you can see how well this summarization works. And the script just runs and performs a summarization, and it's good. We're good to go there. That's happy Dave. Happy Dave. I mean, that's basically it, guys. It's really easy to set this up. Now, if you have any questions at all, please hit me up on YouTube. Like and subscribe. We got lots of cool shit coming, lots of cool open source builds that I'm just, setting up and creating tutorials for. But also on Twitter, on X, Xaruni. Follow me at deagleier_DeFi and send me a DM if you have any questions. All of this is developed through Ren AI. Ren AI is through aggregated AI. It's my AI startup. Oh God, I hope no one watches this. Oh, but yeah, I mean, we build cool shit, guys. Like, that is really all there is to say about it. I hope you enjoyed this video. I hope that this agent stack can be valuable for you. I don't know what else to say. Have a good day.